the Department of Computer Science at the University of Illinois in Chicago. He did his PhD at University of Edinburgh and in AI. And he is, of course, one of the two authors, along with Xinyao Chen, on the book called Lifelong Machine Learning, now in at least its second edition. And Vin's been involved in a number of interesting applications of lifelong learning. He also does a lot of work in sentiment analysis, opinion mining, and generally writes about artificial general intelligence. So today he's going to tell us about continual learning for knowledge accumulation. So Bing, nice to have you here.
Oh, Bing, you're muted.
Sorry. Thank you very much for the invitation. And my talk today is about continual learning for knowledge accumulation. I added one word in front. It's called self-motivated. So this is somewhat similar to Tom's talk, and basically it can be a continuation. And also talk about some sort of things like how do we do this self-motivated kind of learning. So basically, a truly intelligent agent must learn continually, and of course must accumulate knowledge and to make the system more and more powerful. So in the past, especially in the past few years, and the research community has been focusing on this overcoming catastrophic forgetting and how to transfer knowledge across tasks. And for example, we have done something, we did something last year, and which is try to learn a mixed sequence of similar and dissimilar tasks. And when you have a similar task, obviously you have some sort of knowledge to be transferred. When you have a dissimilar task, and they don't really have so much shared knowledge, and in that case, the forgetting will be the major issue. So how do we deal with this two problems at the same time? It's pretty challenging. And although we have made some sort of progress, but it's a very difficult problem. However, if the symbolic knowledge can be learned, and I think forgetting may not be a major issue. Of course, I'm not saying everything should be symbolic, but in some cases, the symbolic knowledge, basic knowledge is important. For example, in natural language processing and question answering, the dialogue kind of situation, you do have a sort of knowledge base, and then that knowledge base can be used to answer questions, to guide the dialogue, all kind of things. So the second thing, the system should have sort of the ability to learn by itself and its own initiative or motivation. So I would like to focus more on that part in this particular talk. So what I mean by self sort of motivation or self-initiative basically means to actively discover new tasks. So instead of being given task and then just learn using that sort of labeled training data given by the human users or human engineers, and how do we make the system to actively discover new tasks and also to acquire ground truth training data, and of course, and lastly, to incrementally learn the new task. So I will try to focus on this particular problem. So here is an example of self-driving cars. As everybody knows, it's really, really challenging to make a self-driving car to reach the human level of driving. And by using only rules and offline training, and mostly initiated by the human engineers, because there are just so many possible corner cases, and which is very difficult to cover. And if you can see on the right, then you see this is a very messy situation. And how does the system sort of behave in this kind of situation? And it's very difficult for the human beings to basically think of all kind of situation and to basically to train the system, to label the data, to train the system, to make the system more and more capable. But in this case, I think we should basically should advocate sort of continual learning to get a system to interact with the environment, with the humans, and in the process learn and all those different kind of situations. And what do we mean by sort of interact with the environment? Obviously, which is very obviously when you come to a situation, you have to interact with the environment to gain some knowledge from the environment. At the same time, you learn from that, sort of whatever things you gain from that. But what do you mean by sort of interact with the humans? I'm talking about some kind of dialogue system, for example, in the self-driving car situation, when you encounter a particular scenario and the self-driving car basically stop, cannot move because don't know what to do. So in this case, you can talk to the human, ask the human what to do next, right? So in the process, essentially you get some sort of ground truth data. And the human tells you, let's say, go left and go right, and then you basically pass this particular obstacles and things like that. And so next time, when a self-driving car sort of encounters this kind of situation, you can basically follow what you have learned previously and navigate through the situation without too much of a problem. So in this case, of course, we're talking about the self-initiation. Of course, it's based on self sort of initiative and then the capability of the car itself, and then to find the path to learn the new situation, and so that in the future, you will not have a problem. So the next example is the chatbot. Just now I mentioned the chatbot. You have to interact with people with sort of natural language, using natural language. So chatbot environment is usually a very open and a kind of dynamic environment. Simply because the human user can say anything that chatbot doesn't know or doesn't understand. So in this case, instead of saying, I don't know, and then basically become not saying anything, or basically sometimes say some nonsense, and the system can learn sort of through some kind of dialogue with humans to gain some knowledge, and then to learn some of the natural language expressions it does not understand before, so that in the future, you basically will understand and also be able to learn, to help to learn in the future situations. So it's very difficult to train, to program the chatbots by the human engineers forever. And this is not an interesting approach either, because we human beings do this kind of learning in our daily conversation and all the time. And we gain a lot of knowledge from our daily conversations. So I use this diagram to illustrate this whole process of continual learning. Of course, many things probably are missing. But anyway, so at the top, we have this sequence of tasks. So continual learning basically means we are learning a sequence of tasks. And here with the task 1, task 2, up to task n+1, which is the new task. And then we have the training data, which is dn+1, and that data goes to the learning algorithm. And then we have this knowledge base. Of course, I don't mean this knowledge base has to be explicit sort of knowledge base. It can be sort of neural nets. It can be sort of a traditional structured database, structured knowledge base, knowledge graph, all this kind of format. Then from this knowledge base, you can feed back some knowledge to go to this learning algorithm, so that sort of past knowledge can be transferred to the new task, and then hopefully to build a better model. So this model goes to the actual application. So in the application process, the model will interact with humans, with the environment. So in the process of interaction, it may have some situations you encounter it cannot understand, that you don't know, it doesn't know how to behave. So in this case, this system should create a new task. Essentially to discover a new task, which is represented the orange line at the top, and that the task goes to the task sequence, and then that task should be learned. Of course, in order to learn this new task, the system basically has to acquire sort of ground truth training data. So in this case, for example, in the self-driving car or even in the chatbots, you can actually talk to the people. You can talk to people, for example, in the passenger in the car. I mean, in the situation of sort of chatbots, you can just basically talk to whatever person that was talking to you. And then you got the training data, and then you can learn this new, go through the same process. Of course, sometimes you can probably gain some knowledge, you can directly put in the knowledge base, for example, a particular relation and a particular facts, you can put directly into the knowledge base. So you can see this become a closed loop. So the system becomes autonomous, and this learner becomes a sort of autonomous learner. And it doesn't really have to be intervened, sort of guided by a human engineer. So how do we achieve this thing? I think it's a very interesting research question. So let me characterize this continuous learning, basically this whole process. Obviously, it's a continuous and incremental learning process, and it involves knowledge transfer and adaptation and across tasks. And then, of course, the most important thing, the system is to accumulate knowledge, and either knowledge base For example, we call it long-term memory. And then also to learn after deployment or something like what do we do on the job learning. So in this case, it has to be self-motivated and self-supervised, using the existing knowledge as gained in the past or been provided by the human engineers, and also through interaction with humans or with the environment. So in this case, it probably involves three main steps. The first thing, of course, is to identify tasks that need to be learned. So in this case, lots of research has been done. So for example, it's called open world learning, or called OOD detection, so it's the auto distribution detection. And then the second thing is to acquire ground truth training data. Basically try to collect training data interactively. Of course, by itself, you can also ask people, and you can ask, probably some other agent which are around and which probably understand this kind of situation, and then ask another AI agent. And then the next thing is to learn the task incrementally. This is essentially the continual learning, what has been researched in the recent years very actively. Let's give two examples. The first example is a greeting bot in a hotel. This bot is supposed to greet a new guest, or the existing guest and new guest, when the person comes to the lobby. So for example, this bot sees an existing guest. He says, "Hello, John, how are you today?" But when you see an unfamiliar guest, and so it does not recognize, and of course, you have to recognize it does not know this particular guest, or it thinks this guest is a new guest. So you should react by saying, "Welcome to my hotel, and what's your name, sir?" So the first issue when you recognize this is a new guest, essentially is the OOD detection. And this also creates a new task to be learned. So when you ask the user, "What's your name, sir?" essentially is trying to get a class label. Okay? So the guest probably will reply, "My name is David," and then that's something like a class label. So in this case, it has a class label, and of course create a task, and then of course you need to get some ground truth training data. So in this case, of course, it's pretty easy. You can just take pictures of David, and then try to learn to recognize David. So the next time when you see David, and then just can say, "Hello, David, how are you today?" So this process, of course, I'm giving is very simple, but in the real world situation, this can be very complicated because it depends on the objective of this agent. If this agent just try to greet the guest instead of other people, then you have to recognize whether this person is a guest or not. It could be some other people come for dinner or come to see the friends. It could be even pets, all this kind of stuff. So you have to characterize the situation, okay, to recognize that this is is it something I should be talking to. Okay, so this process is very complicated. You have to react and how to learn in this reaction process. So I'm just giving a simple example, but the second example is more sort of more realistic in a sort of simple, and the simple is actually quite realistic. So for example, I say I visit Stockholm. User one say, "Hey, I visited Stockholm last week. The place is awesome." So the chatbot say, "Where is Stockholm?" Because the chatbot probably doesn't know this place called Stockholm. And the user could just reply that Stockholm is the capital of Sweden. And so in the next session, and when another user comes in and saying, "I'm planning a tour to Europe next month." So in this case, the chatbot can use the Stockholm knowledge gained in the previous session and to talk to the new user. So, "Are you visiting Stockholm? I heard it's an awesome place." So this is basically you learn, and then you can use the knowledge and it becomes more and more powerful. So in this case, the knowledge can be symbolic in a knowledge graph. And in this case, and also we don't really have a lot of forgetting, okay, unless you want to learn this into the neural nets. And when you have the neural nets, obviously you have more problems of forgetting. So I'm going to briefly discuss two projects which is related to this kind of application. The first one is how to learn to ground natural language, so the expressions or natural language commands during dialogue. So most of the task-oriented chatbots, and I like the many kind of virtual assistants, Siri, Alexa, the Google Home, Google Assistant, or this Cortana, they're essentially natural language interfaces. And what they do is they basically take the user's commands and then match that to some kind of API actions internally, and then basically execute that action, and then basically tell the user the answer. And we propose a system called CML. It's an application-independent approach to building this kind of sort of a natural language interface kind of chatbots. And there was the interactive learning capability. So what do we mean by natural language matching? It basically means it's going to, the user, the application developer is going to write some commands. And then when the user comes to say something, it does the match. Of course, it's more complicated than that because it involves arguments, it involves variables. And then when the system does not understand the new command from the user, and then it does interactive learning. And of course, it basically learns paraphrased this seed command. So you can see this seed command grows, and then next time when the user comes to ask the same question, you will have no problem. So the process is fairly simple. Essentially, when it does not understand the thing, and then you basically have an interactive session with the user and to gain the ground truth of this particular command, what this user wants to do. And then through this process, you can learn this particular thing, and so have no problem in the future. So the next one is how to continue learning factual knowledge.
Sorry to interrupt, just a couple more minutes, another.
Yeah, I'm ending, this is basically the last slide. So this is talking about the continued learning of factual knowledge. So the previous project is about learning new expressions that the chatbot does not understand. This is try to talk about how to learn factual knowledge that the chatbot does not know. So there are many kind of opportunity to learn some new knowledge in the sort of dialogue process. And first thing, of course, the user may say something, and then the system can extract. So sometimes the system can also ask the user for some information. So in this case, I'm talking about when the user asks the system something and the system does not understand. So in this case, then the chatbot can interact with the user and to ask some questions in order to infer. So you can see in this case, the knowledge are represented sort of as a knowledge graph, and basically as triples and stored in the knowledge graph. And then when you come to the interact with the user, essentially decide on what to ask and when to ask, and then to get some supporting facts. And then next step is going to have an inference process. And we need to have a model to infer the answer for the user's original query. And of course, use the acquired knowledge and also the knowledge already in the knowledge base. So in this process, and the system gains the supporting facts, these are the new knowledge, and the inferred one may not be believable, but it can be used and can be saved, and basically can ask some other user to confirm whether this piece of knowledge is correct. And then if it's confirmed to be correct, and then you can save it in knowledge base as well. And in the same way, it basically gets more knowledge. So let me finish. Basically, I'm using too much time. So let me summarize. So as the AI agents are increasingly facing the real world dynamic and the open environment, what I mean by open basically means there's a lot of unknowns, and the system has to basically navigate through the unknowns to learn from the unknowns. And they must learn by themselves after deployment through interaction and with the humans, with the AI systems, with the environment. And the key here is the self-motivation and self-initiate by the agent itself rather than by human engineers. And if we can do this, and then we can sort of have this autonomous agents or autonomous learning systems. And let me end here, and thank you very much, and happy to take some questions.